In this video, what you will learn is how to solve questions involving rates of change and how to find approximate value. Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, my voice will be a little bit deeper, so apologize for that as I have a little bit of flu today. Anyway, in this video, we are looking at a question from Form 5 Chapter 2, which is differentiation. So as usual, y'all can take a look and try it by yourself first. In part A, what we can highlight is these two things. So G is increasing in a rate of 1.2 cm per second, and when G equals to 20 cm, we need to find the rate of change of F. So this actually involves the third application in differentiation, which is rates of change. So if we take rates of change of F as an example, this means that in every second, how much does the F change? So if we want to express this, we can use dF over dt, where t equals to time. So how do we find dF over dt? We can actually use chain rule, where we can split this fraction into two parts. So to fill in these two blank spaces, we need to find an unknown which does not appear in our equation but appear in the question. So what I'm referring to is the unknown G. So we can fill these two blank spaces with dG. So dG over dt is actually given in the question, which is the first thing we highlighted. So this sentence actually describes the rate of change of G. So we can express this as dG over dt equals to 1.2. And for dF over dG, we need to differentiate in order to obtain the equation. But what we need is the original equation first, where F is the subject, or F is on the left side of that equation. So to obtain the equation, we can use this and rearrange it. So the F would be negative 15g over 15 minus g. And now we can differentiate this equation. And we can use quotient rule to solve since it is a fraction. So U represents the numerator, V represents the denominator, and I differentiate it separately. And using quotient rule, we need to multiply these two values first, and we need to minus off the product of these two numbers. And don't forget, we need to divide the denominator again, but with a square. And this will be the final form. And now we can find dF over dt by multiplying the differentiated equation we got just now and dg over dt, which is 1.2. So now there's the issue, what is the value of Q22 sum? So we always need to use the original value, which is highlighted just now, G equals to 20 cm. So this answer means F is decreasing 54 over 5 cm per second. And now let's move on to part B. So we can highlight these two important points. So for the first point's y coordinate, we need to sub p into this equation. So we'll get p and 1 minus p squared. And the second coordinate would be p plus k q. So by looking at part 1, we need to find the first derivative of y, which means it's the equation where we differentiate the first time, or dy over dx. So remember, when we differentiate, we need to separate the equation using positive or negative, and differentiate part by part. So one differentiate will become 0, and this differentiate we need to multiply the power and the number, which is negative 2x. For part 2, what we need to find is the approximate value of Q. We can actually use this equation below, where if we find the Q's original value plus the small changes, we will get the approximate value. So by looking at the diagram, since Q is a y coordinate, we can use the first point's y coordinate, which is 1 minus p squared, as our reference or as the original value before changing. And to find the small changes, we need to use this equation. So the small change represents this delta y. And now we need to find the delta x and dy over dx. So for delta x, it actually represents the changes in the x coordinates for the 2 points. So we can just deduct p plus k with p to get delta x. And for dy over dx, we can actually use the equation from part 1. So the original value of q is 1 minus p squared, and the change of q would be dy over dx multiplied delta x, where delta x is k. And for dy over dx, the x we need to sub the original value inside, which is the first point's x coordinate p. And now we can find the approximate value of q by adding the original value and the small change. So for part B2 actually involves the final application in differentiation, which is small values and approximation. And for the take-home point for this video is, when it comes to questions involving rates of change, we need to use the chain rule. Split the fraction into 2 parts, fill the blank spaces with the unknown which is not in the equation but in the question. And for dx over dt will always be given in the question, but dy dx we need to differentiate from the original equation, which sometimes we need to find out. And when it comes to small changes and approximation, there are 3 formulas. So the first one would be finding the change of y. We need to use dy over dx, which is we need to differentiate, and delta x, which is sometimes in the question will be given. The second formula will be the percentage change, which I will explain in the next video. And lastly, which is to find the approximate value of y. So we need to add 2 things, the original value of y and the small change in y, which can be found from this formula. Alright, so if you are interested in this questions answer scheme, you can click the link in the video description, and if you feel this is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. So I'll see you all very soon in the next video. Thank you.